Okay. Oh, I didn't even label it as geometry. That's fine. Got the date on it. Ooh. All right. What numbers did we do? What? 8 through 30. Good day, Gavin. Good day, I say. Number 8 is 27 degrees. Number 10 is 5. Number 12 is 35. Number 14 and 16 are both proofs. We'll look at those later. Oops, turned too much. Number 18 is no, because the four sides of the quadrilateral are congruent and the diagonals are perpendicular. Since the four sides of the quadrilateral are congruent and the diagonals are perpendicular, the figure is either a square or a rhombus. To be sure that the garden is a square, she also needs to confirm that the diagonals are congruent, right? Okay, number 20. Where is it? There it is. It's a rhombus because the diagonals are perpendicular. Number 22 is a square, rectangle, and a rhombus because all sides are congruent and perpendicular. Number 24 is 9. Number 26 is 66 degrees. 28 is 3 times the square root of 2. 30 is 45 degrees. Excuse me. Which questions do we have on those? 30. Okay. Where I set my, oh, right there. Excuse me. Oh, no, that's not why. That's W. So, let's see. This is T. It says that it's a square, and we're supposed to find the measure of angle WYX. So WYX is this one right there. If it's a square, how big an angle, what is the measure of angle XYZ? What? They're all the same. They're all what? 90. True enough. It's 90. Also, since a square is a rhombus, it has all of the rhombi rules as well, right? So since a square is a rhombus, since that is a rhombus, what's true about the diagonals and the angles, these side angles, vertices. What do the diagonals do to them? They bisect them, which means this is the same as this. And if this is 90, then it splits it in half. What's half of 90? That's a third of 90. What's half of 90? No, that's 2/3 of 90. What's half of 90? You can like pull out your calculator and do 90 divided by 2 if you want. I mean, that's fine. Bruh. Here. Where's your calculator? That's crazy. You keep losing it. Ethan did it. It's always Ethan. You blame your siblings for stuff, Gavin?
Depending on what it is.
Depending on what, you know, you blame them all the time. Of course, they also always blame you, so,
Yeah.
you know, turnabout is fair play. Half of 90, bro. Half of 90. 45. True enough. We did it. What other questions do we have on this one? Sure. We can do 10. 10 says that this quadrilateral is a rhombus. So we get all of those perks. We're on the rhombus package now. Honestly, that would probably be a good way to teach this unit in 2026. Didn't think about it until just now. Number 10 says if the measure of dB equals, excuse me, 2x minus 4 and the measure of PB equals 2x minus 9. Ugly 4, but we get the idea. Now it doesn't look like a 9 anymore. We want to find the measure of PD. But not P Diddy. We figured out his measure. What? What? Oh, nah. Yeah, that's what I think. Oh, nah. Okay, so dB is right here. So this big thing is 2x minus 4. PB is this one. And it's 2x. Oh, that's a missing symbol there. What happened? Minus 9. All right. So, because it's a rhombus, which means it's also a parallelogram and a quadrilateral, but quadrilateral is the most useless thing. Yay, 4 sides. What facts could we use to find x? What happens to, what is true about lay diagonals of le rhombus? They bisect, that's true enough. So this is the same as this. So 2 of these equals this one, right? So we could write that either as this plus itself or 2 times this, either way, right? 2 times 2x minus 9 equals 2x minus 4. Now we can solve that sucker. What should we do? Distribute sounds fine. Let's do it. Two times 2x is 4x. 2 times negative 9 is negative 18 equals 2x minus 4. Now what should we do? Subtract 2x also sounds fine. Four x minus 2x is 2x. Now what? Add what? Add 18 sounds fine and dandy. And we divide by 2x equals 7. Which is not what the book says. Is that why you had a question about it? Yeah. The book says the answer is 5. Looks like a mistake to me. Did you get 7 when you did it? Well, if 2 or 3 are gathered in geometry's name, the key is wrong. Pretty sure that's how that verse goes, right? Okay. What other questions do we have? $14. He's ready for the proof. He's excited. So what do you think, Gavin? We're taking bets. How much snow are we going to get? They're predicting somewhere between 0 and 144 inches. 1 inch in the aggregate of Lubbock, Texas. You could be right.
My honest guess is a 0, but I'm being optimistic.
I see. Yeah, honestly, that's my guess. Honestly, as much as people are freaking out for whatever reason about this particular winter storm, like more than I've seen in a long time, we're probably going to get nothing. That's just kind of how that's probably going to happen.
And then it'll show up in April like it did last year.
Right, exactly. Like that, and nobody will be freaking out then. But man, they've got their toilet paper stocked. We know that. They're all ready. They're not going to run out of toilet paper, man. That's not happening. That looks perfect. Okay. A, B, C, D, F. We are given that A, B, C, D is a parallelogram. And interesting, triangle ABC is congruent to triangle ADC, and we are expected to prove that ABCD is a rhombus. Oh, 15 is what I wrote down, which is not what you asked for. Let's try again. We're still supposed to prove that ABCD is a rhombus, but the picture looks totally different. Let's try again. I think. Oh, no, just kidding. We're not even supposed to. I'm looking at the totally wrong side of the thing. That's why I'm confused. We're not trying to prove anything. There's not an A, B, or C, or a D anywhere to be seen. It's all a lie. The cake is a lie. What? What? The cake is a lie. You don't know what I'm talking about? That's crazy. You have to play Portal, bro. We're supposed to prove that QRST is a square. We are, in fact, given that WZ is parallel to XY. We're also told that WX is parallel to ZY. Yeah. Oh my gosh. I keep looking at the wrong side. What is happening? Bro. Mia's laughing at me. It's very rude. Okay. Try maybe third and final time. We are told that QRST is a parallelogram. We are told that TR is congruent to QS, and the measure of angle QPR is 90 degrees. Really drives me crazy that this book doesn't put degree symbols on angles. It really is irritating to me because it's like very wrong. Because if it doesn't have that symbol, it's in radians, and 90 radians is way different number than 90 degrees. 90 radians, you would have spun around the circle a whole bunch of times. Dumb. Okay, so let's label what we're told. Start with that. Sounds good. So TR, wherever that is, TR, the big one, of course, is the big one, difficult to label, is congruent to QS, right? So those are congruent to each other. And the measure of QPR is, well, that's going to get real messy. This guy right here is congruent to that guy right there. We use our own made-up notation. And this is a 90-degree angle. Great. Get help. What does that say? Why is my computer trying to help me? Get help with your tasks. No. What the heck are you talking about? So this is going to be the year of unasked for AI intrusion. Every company's got to get AI in everything. Pretty soon, then we have all these fancy schmancy Japanese toilets to do all kinds of stuff. That's going to be the thing in 2026. We're going to have AI toilets. It's going to happen. Monitor your health or something. I don't even know what it would do, but it's going to do it. You know I'm right. Okay. All right, so in order to prove it's a square, we need to kind of have a target in mind, right? We need to have like what things can prove something is a square, right? So the longest way, right, is to say all of the things, right? To say that it's got all the sides are congruent. We got to say that all the angles are 90 degrees, right? Got to say all of those things. But if we can prove some of the other things, like if we can prove it's a rhombus, And then we can just grab one of the other things and that'll help, right? Because a square is a rhombus with 90-degree angles, right? So if we can get rhombus or if we can get rectangle from one of the other things, so if we say something about diagonals maybe, or sides or whatever else. We've got that it's a parallelogram, which might be very helpful because that tells us a bunch of stuff. So, what do we want to say? Okay. The pairs are because it's a parallelogram, right? Sure, true enough. We could probably either go through parallel lines cut by transversal theorems. We might could go by triangles on this one. Okay, so QT is congruent to RS, and QR is congruent to TS because opposite sides of a parallelogram. Opposite parallelogram sides congruent. True enough. So this is congruent to this, and this is congruent to that. We don't know they're all congruent yet. They are. We know they are because we can see into the future. We're proving it's a square, right? But we don't know that yet. Okay, so that was helpful. What else can we say? What? Which angle pairs? I can't understand anything you're saying. Q and S, it's not Q and S, but the whole thing. I know what you mean. TQR and RST and all of those things, true enough. We may as well put it. So RQT, angle RQT is congruent to RST, angle RST. Excuse me. And then the other two sets are also congruent. So angle STQ is congruent to SRQ. That's fine. We will likely only use one or the other of these, but not both, but we may as well put them both. That's fine. So this is congruent to this, and this is congruent to this. Now, on a problem like this that gets a bit confusing, and we've got multiple shapes, it can be helpful to kind of pop them out, right, a little bit, because we've got a triangle here and a triangle here, which we know like some sides and some angles. So I'm going to pull this triangle out and this triangle out. Just look at them separately because it's going to be easier to see. So this triangle TRS, that's an A, what's happening? TRS, we've got this side and we've got this tick marks, oh, this one. We've also got this big side is congruent to itself. So we've got triangle, still T and R, right? And Q. We've got this is congruent and this one and this one, right? So that's maybe helpful. We can do the same thing for these triangles as well, right? So we've got this one, which has got a T down here, and a Q up here, an S over there, and then this one, right? It's just got S, and then R, and then Q. And we've got this angle congruent to that angle, and this one, and this one, and that one, and that one. Okay, so now what? We also know their diagonals are congruent to each other. Do we have any theorems with that? Have we used that? Because that's the TR and QS. That we were told from the given. Right? Do we have any theorems with that? If the diagonals are congruent, what shape that gives us? Because if that gives us any, because right now all we know is parallelogram. If we can get any downstream shapes from there, if we can get to rectangle, if we can get to rhombus, then it's going to be easier to get to square, right? So can we say rectangle or rhombus if the diagonals are congruent? Go back and double check. Looking, if it's going to be right there. If what? Which one are you looking at? You're looking at which theorem? 617 or 618? What are you looking at? 618. If one of the diagonals of a parallelogram bisects a pair of opposite angles, then the parallelogram is rhombus. We don't know anything about bisecting angles yet, right? We do actually, it's not what I was talking about, but we do have one of those proofs for a rhombus. Which one do we have on that same page? That's at page 432. 617 we do have, because we're told that this is 90, which means it's a right angle. So real quickly we can put in the dumb step. Oh, this is opposite parallelogram angles congruent. Great. Then we can put in angle QPR is right, because definition, right? It's 90 degrees. Definition of a right angle. Easy peasy, right? We can say that, and since it's a right angle, that means those two lines are what? Perpendicular. Excuse me. So QR, no, not QR, QS is perpendicular to TR, because definition of perpendicular, easy peasy. And then since they're perpendicular, it's a rhombus, and he's got all the bells and whistles of a rhombus, which is good, because a rhombus is very close to saying it's a square, right? QRST is a rhombus because diagonals are perpendicular. Ooh. Right? That's helpful, because now we have all of the things about a rhombus. So all of the things from a page or so back are also true. Also, no, just kidding. I was about to say a lie. I was about to say we also have all the things of a rectangle, but no, we don't, because not all rhombi are rectangles. Okay. So We've got a bunch of other things. We know that it's a rhombus. So we know, what do we know about the fact that it's a rhombus? We know that all four sides are congruent, right? We know that's true because it's a rhombus. Right? So that could be very helpful because that's almost a square, right? Right? Yes, true enough. So, QR is congruent to RS, is congruent to ST, is congruent to TQ. Because sides of a rhombus are congruent. True enough. So all we need is that all the angles are perpendicular. All the angles are right angles, right? So we need angle info. I feel like we might have to do this with some weird math, with some weird shenanigans with math, where we say that it bisects, because that's another thing that's true about a rhombus, and then 90 plus 2 times this, because it's the same. I think. Let me look at what the key says, see if they've got something that's shorter that I'm missing. Or if y'all see something that's shorter that I'm missing, then holler it out. It says it's in the margin, but it's not. It's invisible. Let's look back here. What lesson is this? 6.5. Number 14. This is a perpendicular. We did all that. It's a rhombus. Oh, yeah. Where's that theorem? Where is that sitting? There is a faster way. Oh yeah, the one that's without a picture. What does theorem 6.20 say? Is that our proof is way longer than it needs to be. It's fine. If it's a rectangle and a rhombus, it's a square. We've got it's a rhombus right here. So we can get it's a rectangle. We're great. We're good. We're easy peasy. We're good to go. We actually already have a proof for a rectangle. So you may need to go back and see what those ways you can prove a rectangle are, because we already have it. What's a way to prove a quadrilateral is a rectangle, or a parallelogram is a rectangle that we already have? What? Now flick back to the rectangle chapter, which is like 2 chapters ago, right? Got to flip back over there. What? Yeah, I see all that. What? Huh? You were about to say the right answer. No, well, the converse of, not that one. Which one is that one? The converse of that one. Flip a page forward. But it's the same thing. You were about to say it. What does that tell us? If the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. We were given at the beginning that the diagonals are congruent. So we know it's a rectangle. QR QRST is a rectangle. Diagonals of parallelogram congruent. And since it's a rhombus and a rectangle, it's a square, right? QRST is a square. Rhombus and rectangle. So we didn't need this or this. I think we needed, and actually there's a couple things we said, because it's a thing, we didn't need this. We just needed those, right? Because we needed to prove it's a rhombus and it's a rectangle. But that's okay that we added extra. I don't count off for adding extra. That's fine. And we didn't say anything that's false. It just didn't help us get there. All right, what time is it? Time to learn the last lesson of this chapter. We'll get back to videos and all our kind of normal mode after this chapter. The two quadrilaterals that are not parallelograms, trapezoids and kites. What has happened? How did I end up doing that? Very strange. So, a trapezoid. What is a trapezoid? A trapezoid is a quadrilateral that has one and only one pair of parallel sides. So, kind of the quote-unquote traditional parallelogram is something like that. Right? So, it has one pair of parallel sides. Right? So you could have a trapezoid that looked like that. Now, some vocabulary for trapezoids. You probably have learned about trapezoids before. You probably learned how to find the area of one. The common formula to learn back in middle school, you may not have, but that's fine. These two things, this is called a base. This is called a base. And these are called legs. So the parallel sides are called bases. So even if the trapezoid is this way, these are the parallel sides are still the bases, and these are the legs. It's just on its side if you want to think about it that way, right? Easy peasy. So a specific type of trapezoid, there are a few specific types of trapezoids, one of which is an isosceles trapezoid. And it is what it sounds like it is. So an isosceles triangle is a triangle with two congruent sides. Isosceles trapezoid is one where the legs are congruent. You it would be impossible if you think of, and you can think about it, and you can use your logic brain that we're working on in this class to think about why you couldn't have a trapezoid that had congruent bases. That would be impossible. It wouldn't be a trapezoid anymore, right? Because if these two are congruent, then you have a parallelogram, right? Because then you're going to be stretching these out to be the same. True enough. Making sense so far. There are a few theorems that are true about isosceles trapezoids. One of which is that if it's an isosceles trapezoid, then each pair of base angles are congruent. So in our picture, let me give us some different colors for the different things. In our picture, this angle right here would be congruent to this angle, and this angle would be congruent to that angle. That's, again, that's not for all trapezoids, only isosceles trapezoids, right? You can prove a trapezoid is isosceles if you have at least one pair of base angles. So if we have something like this, and we know that it's a trapezoid because those are parallel and the other ones aren't, if we have one pair of base angles, then it's isosceles, so if you have one pair, then you know the other pair already are. Okay, true enough. Another theorem related to isosceles trapezoids is that if it is an isosceles trapezoid, or it is an isosceles trapezoid, if its diagonals are congruent. Okay. Now, not all trapezoids have congruent sides, right? Like if we draw one that kind of is obviously not going to, something like this right trapezoid here, something like that guy, right? The diagonals are definitely not going to be congruent. This one's going to be longer than that one. But all isosceles ones have congruent diagonals. And it is an isosceles one if the diagonals are congruent. So the forward theorem and the converse are both true, right? Excuse me. Let's do what time is it? Yeah, no, just kidding. Let's look at guided practice 1. So guided practice 1 on page 440 has got a trapezoid on there. Got a trapezoid that looks like it's in a window or something, right? Got some sort of trapezoid here that is labeled X, Y, Z, W. And it has a midpoint of V. And it says to save space at a square table, cafeteria trays often incorporate trapezoids into their design. If WXYZ is an isosceles trapezoid and angle YZW is 45 degrees, YZW, so this one is 45 degrees, right? WV is 15 centimeters. WV is right here, so this is a 15. And VY is 10 centimeters. I think we're gonna not quite finish this lesson today, but we'll see. We'll get what we get done, and we may split it into two. That'll just push your test back a day. I won't cry about that. Be fine. Okay. Let's see. Find each measure. So we're going to start by finding the measure of XWZ. The measure of angle XWZ. So XWZ is this one right here. Right? We are told this is an isosceles trapezoid, which we know this is parallel to this, and we know this is congruent to this. And what else did we just learn about isosceles trapezoids? About their angles. That's true. Its base angles are congruent, which means that this one equals what? It does equal itself. What else does it equal? 45 degrees. Easy peasy. Okay. Then we're supposed to look for angle WXY. WXY. So that's this one up here. Right? So that upper angle. This one is a little trickier, right? This one's more difficult. Right? Because we don't know anything about that upper angle. We got to think. We got to use more than one tool, right? It's kind of like the heart and soul of geometry, is being able to take different pieces, different ideas, and to put them together to get to a solution to our problem, right? So we know that this angle is congruent to that angle. We just said that this one's 45 and that one's 45, right? We also know that this one is congruent to that one, right? We also have a theorem that tells us how to find the sum of the interior angles of a polygon. What is that formula? We were studying it recently, you know it. It's in your flashcards. It's like in the last chapter, not this chapter. I'll give you a hint. It starts with a parentheses. And then the next thing is that. Yeah, n minus 2 times 180. What's the n stand for? Number of what? Sides, true enough. How many sides does our polygon have? 4 sides. 4 minus 2 is 2. What's 2 times 180? 360. 360. So all of these added up together is 360. So 2 times 45 times 45 plus 2 times the measure of angle WXY equals 360. Right? So now what are we going to do to solve that? There aren't any. Too bad. What if we multiply 2 times 45 first? That seems reasonable. What's 2 times 45? We just went through what 90 divided by 2 was, right? So 90. Now what? Probably subtract 90, right? Definitely not the same. That's like me saying, I could either give you $100 for your birthday, or you could give me $100 for your birthday. Same. Now what? Divided by 2. What's 270 divided by 2? Measure of angle WXY equals 135 degrees. Okay. So, let's see what else we can discover in this example. Measure of XZ. Let's see, I don't need all of this anymore. You can go away. The measure of XZ. Okay, so that guy, right? So that's a diagonal of an isosceles trapezoid. What do we know about diagonals of isosceles trapezoids? They're what? True enough, their diagonals are congruent. So if this one is 10 plus 15, then this one is 10 plus 15. So what does it equal? 25. Easy peasy. 25 centimeters, I think, right? Is it centimeters? Yeah. What do you mean what? You're like, that's too easy? Is that the what? Oh. What'd you say? Or did you say 45? No, the diagonal. 10 plus 15 is 25, not 6, 7. Measure of XV. XV is up here. What is its measure going to be? 10 centimeters. This time it is same. This time it is the right answer. 10 centimeters. All right, I'm going to give you the first chunk of homework in this lesson. We should easily be able to get through the last bit because this first chunk of homework is not going to be that difficult. And you have a weekend, so we probably will be light on questions this time. All right, let's do homework. Page 444, numbers 1, 2, 8, and 8 through 11. All. Okay, goodbye. Have a great weekend. Don't get frostbite on your toes or anywhere else. And if we get anything more than 1 inch, just know Gavin was wrong.